Right, so I apologize that this is already filled out, but I had a technical difficulty and the video wasn't able to save. So I'm gonna, instead of rewriting it all, I'm gonna read it through with you, but I'll go nice and slow. So we're gonna set the stage for the first derivative test. Recall that x equals c, x equals that number, is a critical point if the derivative is either 0 or undefined there. Some texts will also use critical values or critical numbers. They're all the same thing. So in example 1, we found actually the critical numbers of x equals 0 and x equals 3. How do we do that? We took a derivative. We noticed that that derivative had no domain restrictions, so there were no places where f prime was undefined. And we set it equal to 0 and found that at these two x values, x equals 0 or x equals 3, that my derivative was 0. So those x values are critical points. Now, how come f of 0 is not a local max or a local min? If we look at it graphically, you can see that my function is changing from decreasing to constant for a really brief second to then decreasing again. This shape does not look like a little hill or a valley. If we didn't have the picture and we had done the increasing and decreasing test, right here at that critical point of x equals 0, we would see on either side of x equals 0 in the domain, my first derivative is negative on either side, meaning my function is decreasing on either side. Going from decreasing to decreasing isn't a max or a min. Now f of 0, which is minus 27, we got that from the graph, is a local min. And how could we see this? Well, if we had the picture, we see that my curve, my function, looks like it has a little valley right here. This y value of minus 27 is the smallest y value for all x values near 3. X values near 3 map to y values that are bigger than f of 3, that are bigger than minus 27. So minus 27, that y value, is a local min. If I didn't have the picture, I still could get this result by interpreting this table here from my increasing and decreasing test. I see at that critical point of x equals 3, my function is changing from decreasing to increasing. Decreasing to increasing looks like a little valley. All right? So we have that written right there. Now, we really have done the first derivative test. The first derivative test is a consequence of my increasing and decreasing test. Increasing and decreasing test. My first derivative test is to find local maximums and minimums. And we do that by interpreting these results from my increasing and decreasing test. So what are our options? If x equals c is a critical point, meaning the derivative is either 0 or undefined at that x value, and my first derivative is changing from positive to negative, meaning my function, right here, positive slopes, then here are negative slopes. So my function is changing from increasing to decreasing. I must have some sort of little hill. Maybe my hill looks like this. Maybe we've got a sharp corner right here. C is a critical point because my derivative doesn't exist at that corner, at that cusp. But since my first derivative is changing from positive to negative, I must have a local max. Remember, maximums and minimums are y values. So we have a local max at x equals c. The local max is f of c. All right? If x equals c is a critical point and my first derivative is changing from negative to positive at that point, we must have a local minimum. So maybe my function looks like this. We've got a critical point at x equals 0. My derivative is, at x equals c, my derivative is 0 here. My derivative is negative to the left and then positive to the right. I must have a local min. My function is changing from decreasing to increasing. Same in this picture. F of c is a local minimum. At the critical point of x equals c, my first derivative is undefined. For x values less than c, my first derivative is negative. Those are all negative slopes. So my function is decreasing. And then for x values bigger than c, my first derivative is positive. Those are positive slopes, so my function must be increasing. Changing from decreasing to increasing manifests a local minimum. Now remember, this is a really common mistake. Just because x equals c is a critical point doesn't mean that you have a local max or min, right? At x equals 0, the y value f of 0 was not a local max or min in example 1 because my function was going from decreasing, constant for a quick second, and then decreasing again. That is not a hill or a valley, no min, no max, right? So here are some general pictures for that. And that concludes our first derivative test.